Okay.
Inert elements.
What?
Inert elements.
Inert mean no reaction. That means inert gases, normal gases. Helium, neon, argon, A2. Okay. So those are all about secondary interaction, right? Okay. Now we are going to discuss solids. Right? Solids. There are two types of solid. Two types of solids. Crystalline solid, amorphous solid. Right? Crystalline solid, amorphous solid. And this crystalline solid has another name, lattice. Right? Okay. What's the difference between crystalline solid and amorphous solid? Crystalline solid means that solid has a regular pattern. Right? Okay. Normally, all matters are composed of their fundamental particles. That fundamental particles may be either ions or atoms or molecule. Right? Ions or atoms or molecule. These are the fundamental particles. Right? So, lattice means or crystalline solids means that particles should be arranged in an ordered regular pattern. Then it is called lattice. Right? Say this is the fundamental particle. If you see that that matter through an electron microscope, then it will appear as like this. Particles will be arranged in an orderly pattern. That means gaps will be same, right? Like this. That is called crystalline solid or lattice. Right? And amorphous solids. Right? We are not going to discuss amorphous solid. We need only lattice. Right? Okay. It's better to know that. Just amorphous solid means no ordered structure or orderly arranged pattern like this. Right? Okay. So these are not considered as true solids. Only crystalline solids are considered as true solids. Right? These are not true solids like pseudo solids. Right? What are the examples for amorphous solid? Normally there are some matters called polymers. Right? You should have studied in O-level polymers. All polymers belongs to amorphous solid. That means all solid state polymers, right? Like plastic, polythene. Oh. Right? Okay. All polymers like plastic, polythene. What else? Those are synthetic polymers or artificial polymers. There are some natural polymers. Protein, cellulose, starch. Those are natural polymers, right? Cellulose. What are the examples for cellulose? Oleo, cloth, right? Cotton. These are crystalline solids or amorphous solids. Amorphous solids. Yours a polymer. Cellulose. Cotton is cellulose, and silk is a protein, right? Silk cloth is a protein, and yeah, what's that? Wood. Leather. Leather is protein because it's normally obtained from what? Leather, right? And what's that? Wood, timber. It's also a polymer, cellulose, right? Yeah. So all polymers belong to amorphous solid. Okay. We should additionally glass. Glass is also amorphous solid. And all polymers. Right? This is the important thing. Just we know that, right? It's better to know that, that's all. Right? Glass and all polymers. Right? Okay. But can you see all thing in electron microscope? In Sri Lanka, we have only two. Totally, we have two electron microscopes, I think, right? So, how can we say if you are provided a solid? How can we say it's crystalline or amorphous? You can't say just by looking at, because glass, normally glass also appear in appearance of glass and crystalline solids will be same. Polymers, yeah, you can say it's there's a difference between these and polymers, right? But glass, right? Okay. These lattice, these solids, that means crystalline solid has a particular sharp melting point and boiling point, especially melting point. Because solids in instant hour then a melting point, clear? Okay. So sharp and particular melting point. That means ice. Ice is a crystalline solid. It starts to melt at 0 degrees C and completes its melting at 0 degrees C. Got it? It starts at 0 and it finishes also at 0. That means sharp melting point. Particular sharp melting point. That's the most important and unique feature of crystalline solid. But amorphous solid, there is no specific melting point. In glass, if you heat the glass, it maybe it starts to melt at just 70 degrees C, and it finishes its melting at about 120, something like that, right? After all glass melts, if you measure the temperature in that liquid, the temperature will be higher than that of initial starting point. So it has no sharp melting. That's the major. Why this has a sharp melting point? Because orderly arranged pattern. So all molecules starts to move at the same time, because between all molecules, all fundamental particles, there is the same type, same strength of intermolecular attraction. Distances are equal, but here no proper regular distance. The distance can vary, right? Okay, that's all. So like this is our title, like this. Okay. See what? There are two types of solids. What? Crystalline solids or lattices and amorphous solid. What's the next point? A formation where the building units are attached to one another in an orderly pattern can be described as a lattice. Presence of a formal pattern and the formation from a repetitive basic unit is a common feature of lattices. Got it? presence of a formal pattern and the formation from a repetitive basic unit is a common feature of lattice, right? Various substances with lattice-like structures exist in nature. Substances with atoms or molecules or ions arranged in orderly lattice pattern exist. Substances with lattice arrangement can be classified according to their building units as follows. Right? There are 4 types of lattice. Got it? Understood? What? Ionic lattice, atomic lattice, metallic lattice, molecular lattice. These are the 4 types of lattice, 4 major types of lattice based on their what? Fundamental particle or repeating unit and the interaction type between themselves. Right? Okay. Ionic lattice, atomic lattice. There's another name for atomic lattice. What? Covalent lattice. Right? Atomic lattice or covalent lattice. Metallic lattice and molecular lattice. Right? Okay. Ionic lattice is what? Its fundamental unit is what are the fundamental units of ionic? Namely, ions. Ions are the fundamental unit. Right? That is cation and an ion. So what are the examples for ionic lattice? All ionic compounds. That's all. All ionic compounds. Okay, this is the fundamental particle. And what are the principal interaction? Ionic bond, that's all, right? And atomic lattice. What are the fundamental particle? Namely, atoms. Fundamental particle, right? Fundamental particle. Next, type of interaction. Type of interaction between the fundamental particle. Fundamental particle or repeating unit, right? Okay. Metallic lattice. We have already discussed. Cations and electron. Right? Metallic cation. Metallic cations and electrons. And what's that? Molecular lattice. What are the fundamental particles? Molecules. Okay. Type of interaction. What? Ionic bond. Covalent bond. Metallic bond. What? Secondary interaction. Good, very good. Right? Secondary interaction. Right? Okay. Right? Okay. Got it? Secondary interaction, right? And okay. There are most subdivisions in atomic lattice and molecular lattice. Right? Atomic lattice, homoatomic lattice, heteroatomic lattice. Homoatomic and heteroatomic, right? And molecular lattice, polar molecular lattice, non-polar molecular lattice. Okay. Right. Now we'll write some examples, right? Ionic lattice. What's the example? For ionic lattice, what's the example? All ionic compounds. All ionic compounds. Atomic lattice. Homo, hetero. Homoatomic lattice examples: carbon, silicon, germanium. In your syllabus, only carbon is enough, but it's better to know these three better: carbon, silicon, germanium. Better because carbon it's a famous and popular one, better, and silicon, germanium. You may have studied in O level in electronics, right? Okay, heteroatomic. SiO2 is the well-known example. I am writing one more: silicon carbide. Only these two. Silicon carbide. SiO2 means silica. Proper IUPAC name is silicon dioxide. Trivial name is silica. Main component is sand, right? And then silicon carbide. That's the IUPAC name. That's a trivial name. You don't need to know. Carborundum. Carborundum, right? Okay, and metallic lattice. What's the example? Old metal. Right? Old metal. Molecular lattice. Polar molecular lattice and non-polar molecular lattice. Right? Okay. Polar molecular lattice example. Yeah. Ice. Right? A polar compound. Ice. What else? Only ice? Ammonia, sorry. That's not famous. Right, ice, ammonia solid, and many more. Right? Non-polar. I2 solid. CO2 solid. What's the common name for CO2 solid? H2O solid. What's the common name for H2O solid? Ice. CO2 solid?
Dry ice.
Dry ice, right? Dry ice. Right? That's the common name for CO2 solid. What's the as I said earlier, what's the interaction? Ionic bond. Atomic lattice, covalent lattice. What? Covalent bond. All metal. What's the interaction in polar molecules? Polar molecular solids. Dipole attraction. Right? In some extreme cases, hydrogen bond. Right? Yeah. Non-polar. London dispersion. Right? Okay. Sorry, you kept it. Another. Polar molecule. What kind of interaction? Dipole attraction and London dispersion force. Only London dispersion force. Okay. Okay. So the type of interaction in these three primary interaction: ionic bond, covalent bond, metallic bond. Here, secondary interaction. Next page. There is a chart. Okay, see that table. Okay. Can you feel that? Yes, you can feel it, right? Okay. Just I will say that. Right? Types of particles. What? Homoatomic lattice, heteroatomic lattice. No. Homoatomic lattice. Homoatoms. Heteroatomic lattice. Heteroatoms. Hetero means what? Homo means same kind. Hetero means different kind. Same kind of atom, carbon. Only carbon, only silicon atom. Two types of atoms, silicon and oxygen, silicon and carbon, right? Right? So homo atoms, hetero atoms, ionic lattice. What are the types of particles? First row, I'm reading the first row. Ionic lattice. What are the ions in the cations and anions? Cations and anion. And what? Metallic lattice. Metallic cation and electrons. Free electrons, delocalized electrons, right? It's better. Right? Okay, metallic cation and electrons. Molecular lattice. Polar molecular lattice. What are the type of particle? What? Polar molecular lattice. Type of particle? Polar molecules. Non-polar molecular lattice. Non-polar molecule. Right? Okay. Interaction. What is the interaction? It's commonly right? Interaction. Covalent lattice. Only covalent bond. I separate a different both. Ionic lattice. Ionic interaction. Ionic bond. Metallic lattice. Metallic bond. Okay. Dipole attraction and London dispersion force. Only London dispersion force. Electric conductivity. Electric conductivity. What about electric conductivity? Only what? Metallic lattice. That a metallic lattice will conduct electricity. And under homoatomic lattice, sometimes. Right? You put it sometimes. Example, graphite. Carbon. This is very important now. Right? Carbon report, and then there are two forms of carbon: graphite, diamond. These are the two popular forms of carbon: graphite and diamond. Only graphite will conduct electricity. Okay, melting point. High. The last two. Polar molecular lattice. Melting point low. Non-polar very low. Okay, low, very low. For a melting point of these three, first four, right, will be high. Why? Melting point and boiling point depends on the type of interaction. For these three, the interaction is what? Primary interaction, very strong. And for that, secondary. Why? Polar molecular lattice. There are two types of attraction: dipole and London. Here only London. Right? Okay. Next, hardness. Hard. And for these two, less hard or soft. Last two. Right? Examples. Example. Write like this. Right? Right? Okay. So fill that.